Hello everyone, welcome back to VLSI for all. I'm Neeraj Cheriala, back with yet another expert talk on VLSI industry and career. And this time we have Anil Tiwari joining us from Ireland. So he's currently working in physical design for GPUs at Qualcomm, Ireland. Prior to this, he's also worked as staff engineer at Western Digital, senior engineer at Samsung, and design engineer at Open Silicon, all in the domain of physical design. So this session is going to be interesting, especially for those folks who are into physical design, since we have got an expert who has got a lots of experience in physical design. So brace yourself for good amount of questions related to physical design. So that was about his career. Anil has got master's degree in VLSI design from Vellore Institute of Technology. He's also got an IEEE publication for low power and area efficient Mac unit for wireless devices. So thank you, Anil, for joining us for this session. We are very glad to have you with us. You are joining from Ireland.
Thank you, Neeraj. Thank you so much for the warm welcome.
Yeah. So before delving into the session, could you please introduce yourselves to the audience? Because we want to hear it from you.
Okay, so most of the things you have already spoken about me. So I have done my BTech in 2011 time frame. I'm a 2011 pass out, basically BTech. And after that, I have joined a software company. So there I was working into a software testing domain. So probably 2-3 years I have worked as a software tester there. So after that, I changed my mind and I thought of getting, knowledge on my technical domain, which was electronics. So I thought of pursuing masters. So after clearing VAT examinations, I got admitted to MTech VLSI design. So in 2017, I passed out from VAT Vellore. So in 2016 to 17, so we have 1 year of internship duration. So there I have done my internship at ST Microelectronics, Greater Noida. So I was there into PDK department, basically process design kits. So I was basically working on the QA part of PDK. So you have all the DRC rules which are mentioned in the DRMs. So basically we used to do the layout and test for the various rules. After that, after completing my internship, I got opportunity as a design engineer, ASIC design engineer into Open Silicon. Hello.
Yep, you're audible now.
Yeah. So I got an opportunity. So after working into Open Silicon, I got opportunity into Samsung Semiconductor. So there I was into foundry department. So after Samsung, I moved into Western Digital, and after Western Digital, I got a chance to come here in Ireland for the GPU team, to work for the GPU team, basically to Qualcomm GPU team. So over the 5 years, like I have mostly worked on PNR activities of PNR block level activities, you can say, which was mainly focused on the area from synthesized netlist till tape out. Basically, it will be PNR, PV, as well as timing closure of the blocks.
So basically, you have worked on all the steps that go into physical design, right? From synthesis to GDS.
Yes. Yeah, I have worked on after the synthesized netlist. So right now I'm planning to move basically to gain some knowledge on synthesis also. So basically, synthesis is basically like you have some RTL code and you synthesize it and get your get level netlist. So till now I was working from synthesized netlist till tape out, but right now my intention is to gain some knowledge over synthesis also. Nowadays the PNR activities is mostly getting saturated. Plus you have all the PNR methodology. You have all the PNR methodology already defined. So basically the most important part right now is the synthesis. We call it as left shift. Left shift is like from the PNR, the placement stage and some part of CTS is already accounted into synthesis. So synthesis is now becoming the backbone of all the PD related work. So it is essential to learn synthesis also. So right now I'm getting chance to do synthesis also for my block.
Okay, that's actually a very interesting point that you have raised regarding physical design domain. So you
Yes.
were saying like PNR is getting automated. In other
Yes.
words,
Yep. So
so
mostly, yeah.
so do you say that students or freshers who have more knowledge on synthesis are considered more valuable in coming days? Is it so?
Yeah, that's true. So basically, synthesis will control your overall flow. So if you come right now, I'm working on Fusion Compiler. So in Fusion Compiler, it will start all the way from synthesis, and you can carry on till placement, CTS, and routing. Everything you can do in a single shell. You don't have to open various other tools also, not like DCG, and then you have to go into ICC2. Now everything is into Fusion Compiler. So Fusion Compiler, you give the floor plan depth to the Fusion Compiler. It will take into account where all the macros are placed and where are all your blockages, routing blockages, placement blockages. So accordingly, it will do the synthesis. So you know how much you can control, you can tune into synthesis, that is more better than doing it into PNR. So in synthesis, you will get lot of control over timing, over area, over power. So synthesis is now becoming a major step in the PNR activity.
Yeah. So since we are talking about synthesis step in specific, and that step which is
Yes.
crucial, as you are saying. So in future, do you think that machine learning algorithms would take over this step synthesis in for physical design?
Machine learning, yeah. I mean, most of the companies have already started working, including machine learning into their flow. Like in my company also, if I can see, like if there is a specific project and there are particularly many revisions of that, like revision A, revision B, revision C. So you can see that through, if I have done revision A, so for all the blocks which are implemented, they will they will collect the important data, like how many CPUs did I use, which machine was good enough to run my block. So they will all collect those data, and so when once I start doing revision B, all those data I do not need to fill. That will be automatically filled. So yeah, I mean, most of the big semiconductor companies have already bought in machine learning, and then you have EDA vendors also, like and cadence. In fact, so it can do automated floor planning also. So many more activities are coming nowadays with machine learning.
Great. So you
Yeah.
say that folks who also have knowledge of machine learning, uh, they will find it easy to find jobs in EDA tools,
Yes,
especially.
exactly. So yeah,
Okay.
so EDA tools are mostly they are asking for a machine learning degree. So I mean that would be very beneficial for the newcomers, especially.
Yeah, that's actually a very good point for all the viewers of this video.
Yes,
Thank you, Anand, for that point.
thank you.
So coming to your career now, you're currently doing a physical design for GPUs at Qualcomm. So
Yes.
the GPUs that you design, that your team designs, do they go into mobile processors of Qualcomm Snapdragon? Am I right? Or are there any other products that these GPUs go into?
So till now, Qualcomm is well known for the mobile processors. The Qualcomm is number one in that, Snapdragon 8. So Qualcomm is number one in that, but obviously, but now we want to gain this number one, number one thing in compute tier also. Like till now, we have our chips, like we have 8 Snapdragon 8C, which are used in the laptops. And recently also Microsoft have launched a laptop which contains Snapdragon 8C. So there is a team in Bangalore which works on the processors, so which are used in mobiles.
Physical
But
design?
right now, this are yes. So in Qualcomm Bangalore, there is a GPU physical design team which will work on the products which will go into mobile. In fact, I'm happy to share that our Qualcomm GPU is much, it is performing way better than A16 GPU also. So that's a good point that we are in the mobile domain, at least our GPU is working better. So, and this team in Ireland, basically we are planning to start a project on a chip which will be going into the compute platform, for the compute platform like laptops. So we will be designing a chips which will be, way bigger than the mobile chips. So our GPU is, along with the other subsystems, they make it Snapdragon 8. In here we will make the GPUs for the computers, for the laptops, basically. Yes.
Yeah, I've heard about Qualcomm Nuvia processors.
Yeah,
So
basically with the acquisition of the Nuvia also, now called you can see the chip in, I can say, late 23, maybe 23 end, our chip will be launched.
yeah, so these GPUs would go along with Nuvia, basically.
Yes, yes.
Okay.
So we are making some scalable architecture, basically. The GPU contains core, basically. So how many core I can put into one chip, the more the cores, more the powerful chip will be. So we have to make some scalable architecture so that, I have one core and I can add 15 more. So it will be 16 core processor. So like that, scalability of any block is very important nowadays. So we have to keep in mind the performance, we have to keep in mind the power also. It's not like that if I'm making a big chip and I can consume any watts of power. So based on that also, we have to, there are two KPIs. Basically, KPIs are key performance indicators. You can say performance per watt and performance per area. So if you want to increase your KPI, you have to decrease your wattage, you have to decrease your area. So area will benefit me in the foundry cost, basically. So nowadays people are fighting for the area more than the power.
Yeah,
Or
the
at
chip
least I can
shortage
say
thing.
in the computer domain, a little bit more power than the mobile domain is acceptable.
Yeah, that's right. Actually, the area thing which you have raised, I mean, the chip shortage is
Yeah,
also going on.
chip shortage, exactly. Yeah.
Yeah.
And for a fact that if I can say a 5 nanometer, I have read it somewhere, a 5 nanometer wafer will cost you around $20,000. A wafer of 300 mm, it will cost you around $20,000. So you can see like how much expensive it is getting nowadays.
Yeah, and the demand surges as the chip shortage goes on.
Yes, yes, exactly.
Cool. And you've talked about Qualcomm products, Qualcomm team that you're working with. What about
Yes.
the physical design that you have done at other firms, Western Digital and Samsung? What were the products, the end products?
In Western Digital, I can say my end products were the portable hard disk, which you have seen. The Western Digital or the SanDisk launches every month or so a new hard disk. So the end product was mainly for the hard disk, the memory controllers. And in Samsung, I was basically into foundry team. So there are two teams like LSI and foundry in Samsung. So LSI division will work on the Samsung projects. Foundry team, they have association with the Samsung foundry. They will take the projects from other customers, they will do it at their end, and they will give it to the foundry. So in that, while I was in Samsung, I had some networking chip project going on. It was on 8 nanometer. So based on customers demand, we do some changes into the project, and then we give it to the foundry. So basically, foundry division is a separate from LSI.
Okay, so in the foundry division, do the customer gives you a pre-built physical design layout, let's say, or else
Uh,
do you build it from
yeah,
scratch, from
ba-
synthesis?
uh, basically, I have done two projects in Samsung Foundry, so they have given the synthesis netlist. So we started from that. The RTL, mostly all the customer wants that they keep it on their side because of what can I say, confidentiality issues. So the customer will want to keep the RTL from at their side only.
Yeah, got it. So you have worked on technology nodes ranging from 16 nanometer to 5 nanometer. So what are the differences with respect to physical design when the technology node shrinks? I mean, are there any methodology changes in the physical design flow?
Yeah, definitely the methodology changes from 16 nanometer, right? Like right now I'm working on a 3 nanometer and I have recently worked with 4 nanometer. So methodology has to change. There are more number of metal stacks which you have to take into account. You have to redefine your power grid structures. Then there are a lot of base rules which come into picture. You know, with the rules which are given by the foundry team. You know, you can't place your physical cell like anywhere. You can't place your memories. You have to maintain certain distance between the memories. You have to maintain certain distance between memory and the standard cells. So there are a lot of these base rules comes into picture. Then there is a concept of masking also. So in terms of DRC, you have a lot of challenges which comes into the lower technology nodes.
Yeah, so apart from DRC, are there any other
Yes.
changes?
So methodology changes wise, in the sense you will have a lot of timing issues as the technology is shrinking. You will have a lot of SI issues. You will have, you know, the power issues. The density of the standard cell is getting higher. Then you will see the IR drop issues. You will have the SI challenges of itself. So yeah, I mean, and the frequency is also getting higher. So you'll face a lot of difficulties in closing the timing, basically.
Yeah, got it. That gives us an idea about it. Uh,
Yeah.
so you were mentioning the 3 nanometer, 4 nanometer technology nodes. I mean, I guess it must be at Qualcomm you're currently working. Am I right?
Yes, yes,
Okay,
yes.
great. So Qualcomm is already at the forefront. I mean, working at 3 nanometer technology. I guess they've given it to TSMC Foundry.
Yeah. Um, yes, yes. Basically, Samsung Foundry have some yield issues. So yield matters, right? Out of a single paper, how many chips you have at the final place, that will matter a lot. So yield issues are important. So TSMC is like way ahead. I mean, not way ahead. I mean, it is ahead of Samsung Foundry at least in 3 nanometer.
Great. So talking about the tools now. So you have worked at several firms. I mean, all in the physical design domain. So were there any tool changes that you had to go through? I mean, at one firm you may be using a separate set of tools, and
Yes, yes.
when you go to other firm, you may have to use a different set of tools. So when
Yeah.
there is a change of set of tools, how different did it feel for you, and how easy was it to migrate from one set of tools to another?
So basically, like I've started my career in Innovus, and later I moved to Samsung. Then there also I worked in Innovus, but there were one or two blocks which needed to be done in ICC2. So I have to learn ICC2 in that aspect. Uh, but there will be only two classes of tools, either Cadence or either Synopsys. So once you learn any tool, it's easy to migrate to the other tool. It's not that difficult, because what has happened is, like, when if you talk about timing closure, then PrimeTime is the best tool, the industry standard tool, I can say. So once so I was working in Innovus, but then I had to close my timing in PrimeTime. So I had to learn the PrimeTime commands. So once I started using ICC2, I saw that the commands which are used in PrimeTime are similar in ICC2. The ICC2 GUI is a bit different, but the commands like get cells, get nets, get pins. So these commands are, we can use it any place. So right now also I have started working on Fusion compiler. I don't have prior knowledge in Fusion compiler, but yeah, you should have like what you want to do, and then there is always a support site in which you can put in your queries, and then you will get the command. But you should have the knowledge of what you want to do. The steps of PNR will remain the same. Yeah.
Yeah, so anyone who wants to get into physical design, they basically should not worry about the tools.
Yeah, they don't need to worry about the tools. Anyways, one or the other tool you have to work on.
Yeah,
And then if you learn both the tools, it's good. But yeah, it's not that difficult to migrate from one tool to another.
got it, Anil.
Yeah.
So you have worked on physical design for several class of, products. I mean, just as you mentioned before, you have worked with
Yes.
design for memory controllers, and now we are working on GPUs. So, are there any differences with respect to these products when we do physical design? I mean, physical design for GPUs, how different it is when compared to physical design for memory controllers, let's say.
So if I want to talk purely on the perspective of physical design, it's not uh, that different, but at the end you will have one block, you will be given some B box, you will be given some memories, you will be given some standard cells, and to complete your, which I haven't observed as of now because I haven't worked on the top level PNR activities in which we do the partitioning and all. But at the block level, if I am working, maybe the difference would be on the frequency. Like if I am working on CPU, the frequency will be more than 1 gigahertz. But if I am working like memory controller on which I was working, it will have frequency of 700 megahertz. So CPU will have its own challenges of closing the timing. Memory controller will have its own challenges. Like in memory controllers, you have to focus more on power side. So I mean, there are some differences. CPU versus GPU, you have CPUs are more having more speed than GPU basically. So there will be different set of challenges in CPU as compared to GPUs or vice versa or memory controllers. So yeah, but at a block level, a PNR activity there is not no much change.
Got it. So basically, the
Yeah.
power and timing aspect will be different.
Yes, basically. Yeah.
Okay, got it. So currently, you're working with an on-site offer. So can you
Yeah.
give the audience tips on cracking an on-site offer? You're working in Bangalore prior to this. So
Yes,
how
yes.
do the audience go about cracking an on-site offer, especially in VLSI design?
So what I want to say is like India itself uh, is expanding very much in VLSI field. Most of the semiconductor giants have already their main, apart from head offices, they have their main R&D center in India. So the chances of coming, uh, you know, going abroad in VLSI are very slim. So basically, most of the companies are investing in India itself rather than bringing the talent to their country. It's a bit expensive. So they are investing in India itself. So for me, it was like uh, I applied it through LinkedIn. I was like, all of my jobs like I applied through LinkedIn. So I would like to suggest that LinkedIn is more important. I mean, is the most important app in your mobile. So use LinkedIn wisely, basically. Uh, I applied it and I thought that like they won't be calling me because they have talent itself in USA, they have talent itself here in Ireland.
Yeah, this
So,
is actually
but
the concern of many students.
yeah, so it's a bit difficult. As far as USA is concerned, they don't call you directly until and unless you have the MS from USA. So the easier way, if you can do MS in USA or masters in any other countries, and from there you will get a chance to work abroad. But in India, the getting into abroad is very slim. But I applied it and uh, I was not thinking about it. I just applied it over the LinkedIn post, and then I got a call and for the interviews. But I can say that the interviews were very tough. There were 6 rounds of interviews. In India, it's generally 3 or 4 rounds of interviews. So 6 rounds of interviews. I left the hope basically. It took 2 3 months of around 2 3 months of time for all the interviews to happen. But at last, I got a chance to work here. I came here like just to have an glimpse like how the things work here abroad. So I finally I will come back to India.
So you have a plan to come back to India again.
Yeah, definitely. I'm missing few things uh, from in India. Yeah.
Interesting. So how was the
Yes.
interview? I mean, how different was it when compared to the Indian versions?
In India, basically, what can I say? The interview here, the people mostly target the basics kind of thing. After having 5 years of experience in piano, also one of the interviewer asked me to draw and get from access, and he went into very, very basic things like digital electronics. And digital electronics is one of my favorite subject. So I constantly brush up with digital electronics, the notes which I prepared during my GATE exams. So they were like, uh, so in India, people, uh, you have to answer it correctly, most of the answers, most of the questions. But here, even to they are a bit convinced. So yeah, I can say that for clearing the interviews from here, your basic should be very good. They want, they don't want like you should be an extreme intelligent coder, but you should know how the, where to put the loops and where how the code will work. Basically, the idea. So that's all they wanted to know.
And what took 6 interviews, 6 rounds of interview? I mean,
Yeah,
what were they focusing in all those rounds? I mean, a lot of rounds.
in the first round, the manager took like what are the steps in PNR activities, and also that was a basic round. In the second round, basically, my manager took my interview and he asked only two questions. What did you do in your last project, and how did you mitigate the challenges which you see in your last projects? And we discussed for 1.5 hours about only a single some power issues was there in one of the blocks, and we discussed on that. And in other rounds, there were separate rounds based on, there was one separate round on low power, there was one separate round on routing, there was one separate round on timing closure, there was one separate round on PV. So they have this separate rounds of all the stages.
Okay, so separate rounds for each of the stages. So that
Yes,
makes it
yes.
6 rounds. Okay,
Yeah.
okay, got it. So for students who want to get into physical design, there's often no proper open material available to study physical design and to start with physical design. I mean, there's a lot of open material present for RTL design. I mean, the front end design, but physical design it's very sparse. So could you point any resources to get started with physical design?
In the physical design, if I can say, uh, you have a lot of materials in over the sites also. The steps will remain same. So
Yeah.
coming to the materials, the PNR structure will remain same. Uh,
Okay.
it will have all the steps like placement, CTS, routing, but the in-depth stages for that you have to, what can I say? Basically, you have to get into some company or get some courses done uh, from the institutes. So you will
Okay.
have in-depth knowledge of the PNR. So in terms of timing, like I used to read STA by J. Bhaskar, STA for Nanometric Design by J. Bhaskar,
Okay.
a book. Yeah. So I used to clear my basics of timing. I mean, if you read, if you go through that book, your basics of timing will be very clear, and you will be able to clear any interview very easily. So physical design, luckily I got chance after I was passed out. I got a chance directly to work on a at a industry standard. So uh, I didn't have to search more about that.
Yeah. So are you talking about the ST internship?
ST internship. So my ST internship was basically into layouts. So I used to do. Interestingly, during my master's, one of my favorite subject was analog. So, and my favorite tool was Cadence Virtuoso. So I used to love layouts, analog layouts and all. But then I was more interested into physical design, because everyone used to say that physical design is booming. So I got attracted towards physical design, and luckily I got placement in Open Silicon into physical design team. So I started my career like that.
Yeah, but
So
analog domain is niche kind of. I mean, there are only few people who do analog. So why didn't
yes,
you
yes.
continue in analog?
Maybe I was finding analog very tough. I used to score very less in my masters in analog, basically, and that Bezat Razavi book, my professor made me to study. So I was like not liking, yeah, but analog is a niche domain. I mean, it has also a very good career perspective, career growth in analog domain also. That's true.
Yeah, but physical design is also niche. I mean, because we don't find many working in physical design as well.
Physical design, SCA, yeah, mostly you can add synthesis also, basically. Now STA synthesis, physical design, yeah, synthesis is also getting more important.
Yeah. I mean, one point that audience will note down from this session is the synthesis step which you were talking about. You also mentioned
Yes,
this point earlier as well.
yes,
So nowadays synthesis has become the important step because
yes, correct.
PNR is mostly automated as you were saying.
Yeah, true that.
Got it. So coming to projects now, especially for freshers, projects add to their resume. I mean,
Yes.
recruiters would look at the projects when they interview a candidate, and based on that, the decision would be taken most of the times for freshers. So let's say for RTL design, we simply have projects of designing some circuits or verifying some circuits. But
Mm-hmm.
what about physical design? I mean, how should the students go about taking the problem statement for physical design?
Basically, uh, it all depends on from where you are doing the physical design course, or maybe you are studying physical design uh, in some college or in some institute. So the problem statement for physical design is like you can do a friendship with a guy who is doing the RTL, who is writing RTL, and then you can do the synthesis for that RTL code and start your PNR, PNR steps. Like the in VIT where I studied, so they had different sessions. So they have different, subjects for this ASIC physical design and STA, and in that we have to do our project. So we used to get a netlist directly, and then we used to follow all the steps of PNR. So my point is like it all depends from where are you. You know, there are some institutions which provide physical design trainings also, or you can join into some master's courses where you will definitely get a chance to do a physical design course or the subject.
And are there any open source tools for physical design apart from Cadence and Syllabus?
Basically, I have not worked, and I have not tried to search basically, but there may be. I was going through some of the site like vlsiacademy.org is there. So in that you have different tools which are already listed down there. So from that you can try, and maybe I have heard that Google has also created some open source which can be used for circuit designing. Uh, yeah, but I haven't used personally any of this.
Okay, got it, Anna.
Yeah.
So coming back to your career now. So you've
Yes.
worked at several firms. So what were some of the interesting projects for you with respect to physical design till date? Most interesting
Interest,
projects.
interesting projects were like in Samsung also we had one block uh, which was area critical, and the inst count was more than 2 million, and there were it was macro dominated block. I mean it had around 80 macros. So the floor planning of that block was a bit challenging. In Western Digital, I had one block which I handled is like which was timing and power critical. So there was some area which was showing a lot of IR drop, and then step by step, uh, I have to reduce that IR drop. So seeing the timing margin of the cells which are present in that IR drop area, I have to change. I have to do the VT swaps So basically, I have to keep in mind both the things. The timing should not degrade, and I have to reduce this IR drop also. So that was challenging. And here in Qualcomm, I have just started. I think it will be very challenging to close the blocks. We are targeting around 1.4 gigahertz of frequency. So let's see how it goes.
Yeah, so the timing closure would be challenging.
Yes, yes.
And have you done scripting? No, I mean Python scripting during
Uh,
this
no,
experience?
actually, I have not done Python scripting, but I can say like Python. I am seeing a lot of scripts which are done in Python in Qualcomm. So or most for post processing the data, they have written a lot of good scripts in Python. So Python is nowadays becoming more important than Perl or Tickle. So most of the once you start working over the tool like ICC2, Primetime, or anywhere like Innovas, you will get to know about Tickle. So anyhow, you will learn Tickle in the process PCL. So, but you know, Python is a language like you have to do a separate course or you should learn of your own and start scripting because Python is very easy language. I mean, everyone says I haven't used and you have uh, you know for the post processing the Python is a very good scripting language. It can draw some very good charts, very good information graphs, and also it will be a definitely a game changer if you post process using Python. I have started use learning Python, so let's see.
So can we say that Python will be an added benefit to the resume?
Definitely Python nowadays will be definitely an added benefit. Yeah.
So thank you for all the answers, Anil. We are almost at the end of the session now. Just a couple of questions before we call it a day.
Yeah.
So, what's your opinion on VLSI for all and our initiative?
This initiative is like I think it's very good. It's very great initiative. You are having all the experts, VLSI experts. Maybe I am not that expert, but yeah, you are having all other experts to have a talk, and maybe uh, all the freshers uh, will take a full advantage of this and note down some important points, maybe, and then they can, they can decide on whether which field they want to go, whether it be analog, whether it be digital, or they want to go into RTL domain, they want to go into physical or STA domain or power domain. So yeah, from this they can take away a few key points basically. So it's a good initiative basically. At our time, we had, but we had very less of this kind of initiatives maybe. But nowadays, yeah, it's good initiative.
Yeah, thank you for those generous words.
Yeah.
So, as you were saying in the middle of the session as well about growth of VLSI industry in India. So,
Yes, yes.
what's your point on this growth in coming near future? I mean, what do you expect?
Uh, Growth of India means the growth of the people who are residing in India basically.
I
So
mean, VLSI
definitely,
design.
yeah, yeah. So definitely, like the students will have more options as all the companies are putting their headquarters in India. Even now, Tata would build a semiconductor plant in India. So seeing those things, definitely you will have a lot of opportunities. Maybe you will get the students will get a chance to work into the foundries as well if we have one two foundries in India. Otherwise, what happens is like you have to go to TSMC, you have to go basically you have to go to Taiwan to work into foundry level. So in India itself, you will get a chance, and then lot of other engineering companies, lot of other service-based companies, or lot of product-based companies will expand their network in India, and you will have a lot of opportunities into VLSI.
Great, and that should equally motivate the students who are pursuing VLSI design.
Exactly. Yes.
Yeah. So when you look back almost 5 years ago, when you have started your career in VLSI after doing masters, so what do you suggest young Anil who was just starting his career? I mean, with regards to career and also life motivation?
So basically, you as a life motivation is like you have to work hard. Uh, that's the basic thing. You have to work smart also. You have to be, you know, very fast in grabbing the opportunities. You have to keep an eye, as I said, over the LinkedIn. You have to, if you see the job posting, you have to apply it. If I would have thought that, the these people from here, Ireland, won't call me for interviews and they won't take me, I would have lost this opportunity. But what I did is like it hardly took me 2 minutes to apply over the LinkedIn, and finally I'm here. So that's what I mean. You have to do your work, your part of work, and then the rest follows. You have to at least apply as a first step. You have to apply. You have to apply for all the opportunities. You have to, you have to keep in contact various HR of the companies. You have to get in contact with various HRs, so you can see all their job postings and all. The first thing after getting up in the morning I do is like I scroll my LinkedIn post. So everything, it starts with a LinkedIn for me. I have around 11,000 connections, and some people say like you don't know him or you don't know that guy, then why are you friend of him? It's not like getting increasing your friendship over the LinkedIn. It's like it's a connection which will help you to get your job faster. So that's my point. And 5 years back, I was like an average student in VIT, which was, what has happened is like I skipped. We had a subject in digital design, and I skipped the timing analysis part. I was like not getting the setup and hold time, so I skipped that concept in the exam. So during the interview also I was not knowing. I mean that internship interviews, I was not knowing what is setup, what is hold time. I thought let it be. So I cleared my interview even though. But after coming, when once I get the full time opportunity, I came in this PNR industry, and everyone was talking about setup and hold time only. So I thought that, oh, that was an important concept which I skipped. So then I looked upon various videos, and I came to know that like without setup and hold, no one can survive in physical design domain at least. So I started learning about that. I looked upon various YouTube videos, other sites to get a good command over that. So it's like at that point of time, you never know like what is important for your future. So that's what. And I would like to suggest that you should do your project wisely, because as a fresher, most of the companies will ask for your projects only. What you have done during your internship, what you have done, what are your thesis, what are your projects. So they will ask the questions based on that only. Until now, also some of few of the companies like they ask me about uh, what was your project, and I hardly remember something, and I say that okay, yeah, this was my project at the master levels. So projects are that important. Yeah.
Yeah, so basically, as you were saying, if I can summarize, one thing
Yeah.
was be prepared and be ready for the opportunities to grab the
Yes.
opportunities.
Yes.
And growing network is always beneficial, as you were
Yes.
saying. And
Yeah,
by the way,
true that.
we'll also pin your LinkedIn profile with a post that will be posted. So
Yeah, sure.
Anil Tiwari is also on LinkedIn. And the
Yes.
other one is the projects which you were talking about, and also
Yes.
the basic concepts that you learn I mean, at your university. So those are also
Yes.
important.
Yes.
Yeah, got it. And that should help the audience to assess all those important things when they just transition from academia to industry.
Yeah, exactly.
Yeah, got it, Anil. Yeah, thank you for all the suggestions and all the answers that you have provided us in this session. I guess
Yeah.
those should definitely help students to bootstrap their career, especially in VLSI design or physical design. And you have also mentioned about your experience working in physical design. Thank you for all those explanations that you have provided us in this session. We
Yeah.
look forward to collaborate with you in near future as well. Thank you, Anil. Thank you for joining us from Ireland this time.
Yeah. Thank you, Neeraj. For me,
Yeah.
it's I mean, it's 7, so
Okay.
it's okay for me.
Okay.
Yeah.
So
Oh,
thank you all for joining
thank you,
this
Neeraj.
session. Yeah. So that's actually the wrap up for this session. Thank you for joining this session. I hope all the audience get new things from this session and they'll learn from this session. Thank you all. We'll be coming back with yet another expert talk and VLSI industry and career. So stay tuned to VLSI Talk. Goodbye.